Hello, welcome to my channel. We will be solving this previous exam. We started it 2 days ago, I guess. So we are doing this May-June 2025 exam, and this mathematics for mechanics. Okay, we already solved 4 questions. So we will be doing question number 5 today. Okay, yes, here we go for question number 5 here. Okay, so it's interesting scenario that you have this uh, thing, a straight horizontal surface and a inclined surface. On inclined surface, you have an object of 3 kilogram. On plane horizontal surface, we have an object of 4 kilogram, and here we have an object of 5 kilogram, which is hanging freely. Okay, this surface, the inclined surface, this is rough, so it has some friction. But this horizontal surface, it is frictionless. There's no friction on it. Okay, so we are told that it is the whole assembly of these one, two, three objects, three masses. It is moving in this direction. Okay, and it has an acceleration of. I believe the acceleration is given somewhere here. Three. I'm sure I'm seeing it somewhere. Okay. Yes, the system is released from rest. In the subsequent motion, C moves vertically downward with an acceleration of 2 meter per second square. Okay, so if this has acceleration of 2 meter per second square, then the whole assembly has the same acceleration, right? Okay, so um, first task is we have to find the tension in each of the strings. Okay, we have to find the tension in each of the strings. So let me make it a little small. Okay, so I will start with string number in this last one. You see this object, this which is C, it has its weight is acting downward, which is M of C G, right? So the force acting downward is its weight, and the force acting upward is the tension. And since there are two wires, two strings, one is between B and C, one is between A and B. So I will call this tension between B and C. So I will call it TBC. Okay. So of course MCG is larger, that's why it is moving downward, and it has an acceleration of 2 meter per second square, right? Okay. So if I analyze this condition of C, you can imagine that MCG minus TBC is equal to MC into A. Does it make sense? You see, the net force on this on the subject C is this one, the left one, whatever I wrote on the left side of the equation, and that force is equal to mass and acceleration. Okay. Now from this expression, you can see I can isolate TBC, and this is going to be MC. If I take it common, and I could have G minus A. Am I right? Yeah, G minus A. Okay. MC is known as 5 kilogram and G is 10 minus 2. So this is 8 times 5. This is 40 Newton. Okay. So 40 Newton is the tension in the string BC. Okay. Uh, okay. Now let's analyze this object, this mass B. Okay. This mass B, since it's on frictionless surface, so we will not we don't have to worry about the friction. Okay, since it's moving this way, so this tension is TBC and this tension is TAB, and of course TBC is larger than TAB. is AB, 10, BC is larger than AB, and it's going in this direction with an acceleration of 2 meter per second square. So I will write this equation for object B. This is for C. Now I'm writing the equation for B. Okay. So as I said before, TBC is larger. So TBC minus TAB, this is equal to MBA. Okay. So from here, you can see that TAB would be equal to TBC minus MB into A. So TBC is already calculated as 40 Newton minus MB. Mass of the object B was 4 kilogram. So 4 and acceleration was 2. So 8 and 40 minus 8 is 32 Newton. This is the tension in the other string. Okay, so we solve part A. Now in part B, find the coefficient of friction between the A and the inclined plane. Okay, now here we will analyze the object A. It is on the inclined surface. This is A. Okay, now it is going up. What are the forces acting on it? One force is the horizontal component of the weight. I shouldn't say horizontal component. This is the component of the weight which is trying to slide it down. And you remember this component is mg sine theta. Okay, so I will say ma into g into sine of, I believe it's 30 degree. The angle of this inclination is 30 degree, yes. Okay, so 30 degree. So this is the force which is trying to slide it down. Now, there's another force which is resisting its motion, and that is the frictional force, right? And frictional force is mu into n. Mu is, we need to find out. And this normal force, I hope you remember, it is m a g into cos theta. So this is cos of 30 degree. Okay. So if I apply all the forces on it, and there was a tension here, which was tension AB, and the force of friction is also acting in this direction, force of friction. Okay, so if I apply all these forces, then TAB is the largest minus MA capital G sine of 30 degree is 1 by 2, and minus this force, which is U, again MA, and the G and cos of 30 degrees under root 3 by 2. Okay, so if I rearrange these equations, I want to find this mu thing. So mu MA G and under root 3 by 2 is equal, oh, what is this equal to? Sorry. So this is the net force, and this is equal to MA into A. Okay. The net force is equal to mass times acceleration. So I'm analyzing these things. I took it on the other side. So I have TAB here minus MAG into 1 by 2. And this goes on the other side. And it will be minus MA into A. Let me make sure that I'm doing everything is right. It is 32 minus, yes. Okay. No, I will get right. Okay, now TAB was 32. Am I right? We just found it here. TAB is 32 Newton. Okay. Minus MA. What was the mass of A? It was 3 kilogram. So 3 into 10 is 30. 30 times 1 by 2 is 15. Minus again MA is 3. 3 times 2 is 6. Okay. So this would be 32 minus 15 minus 6. So it's 11 only. And from here, we can compute the nearly the coefficient of friction is 11 divided by MA. This is capital A. MA is MA into G is 30 and under root 3 over 2 is um, 2. So it will be 11 over 15 under 3. So let me calculate it. 11 divided by 15 under 3. And this comes out to be 0.423. Okay, this is the coefficient of friction. I hope you understand all the logic I'm using here. Okay, that is important. Okay, last part of the question is find the total distance that A moves, travels up the plane from the instant that the system is released from rest to instant. Okay, so now what happens while this object, it was accelerating, moving up the slope. After 1.5 second, this string broke. Okay, when the string broke, uh, it will not be. It is this object is not being pushed up anymore. Okay, rather at the moment when the string was broken, it has some speed, so it will keep moving up until it stops due to the inclination. Right? So we have to find the total distance it will travel before stopping. Okay, find the total distance that A travels up the plane from the instant that the system is released from rest from this point to the instant that A comes to instantaneous rest. So there are three things. Here, velocity was 0. Here, the velocity was maximum. And then after some time, it stops again. So velocity is 0 again. Okay, so we have to find the total distance it travels. So first, let's just calculate the distance it will go from here to here. Okay, let me, okay, this distance we want to find out first. Okay, okay, this is a bit easy. We know that the distance is equal to VIT plus half AT square. Now, in this case, initial speed was 0, so I don't need to worry about this one. Half, and acceleration is also given. This is a big plus. We know that the object was accelerating up with an acceleration of 2 meter per second square into, and time is also given 1.5 second. So 1.5 minutes square. So 1.5 square is 2.25 meter. Okay, so this was easy. This is the distance it will travel while the string was not broken. Okay, now the moment the string is broken, I had to find out the distance it will travel. Now there are several problems. When the string is broken, I do not know what was its speed. Okay, I have no idea how much the deceleration. I have no idea how much distance it has traveled. I have no idea how much time it will take. The only thing I know is that it stops, so the final velocity was 0. Okay, so let's calculate the velocity over here, which I wrote velocity maximum. How much is this velocity? Remember, Vf equals Vi plus At. So initially speed was 0, so I will say 0 plus acceleration was 2 meter per second square and the time was 1.5 second. So this is 3 meter per second. This was easy. Okay. Okay. Now, in order to do anything, I need to know the acceleration. Without acceleration, I cannot find the time, I cannot find the distance. So I need to know the acceleration. Okay. That is a little complicated. You see, when it is going up, uh, okay, you see, at this point, the object was moving up because it was moving up, right? It has some upward velocity. Okay. Now its speed is becoming smaller and smaller. It will stop, right? So why it will stop? Because there are two forces acting on it. One is its weight, which is trying to pull it down, and one is the frictional force, which is resisting its movement, right? So how much is this? The first force, the force which is trying to bring it, slide it down, that force is m a g into sine of 30 degree, right? This is the force that is trying to pull it down. Okay, plus the frictional force is mu m a g cos of 30 degree. Okay, and this total force is causing this mass to deaccelerate. So I will calculate the acceleration from here. Okay, uh, so total force is equal to mass into acceleration. Okay, now you can see that I can cancel MA throughout. This is a good thing. So I have only G, which is 10, and sine theta is half, plus mu, we have calculated 0 0.423, and MA I have already cancelled throughout into G, which is 10, and cosine of theta is square root 3 over 2 and equals A. Okay, so this is how I can calculate the acceleration or deceleration of this object after the string is broken. So let me calculate this thing quickly. It is going to be 5 plus 0.423 times square root 3 over 2. So this whole thing comes out to be 5.37 meter per second square, and I should call it negative because it is actually the acceleration. Okay, if I just consider the forces in the negative direction, then I will have A as negative as well, but this is not so important. Okay, so now I know that from this point onward the acceleration was this much. So now I can calculate that how much distance it will travel before it stops. Remember the equation 2as equals Vf squared minus Vi squared. So from here, S is equal to Vf squared minus Vi squared over 2a. Now final speed is 0. Initial speed, we have calculated that at this point, its speed was 3 meter per second. So this is 3 square divided by 2, and acceleration we just found out minus 5.37. Did I do this math correctly? I think I made some mistake here. Uh, it is 5 plus 5. Yeah. I'm having some trouble here. Okay. Okay. I did not multiply it. No, I think, yes, I think it is a, okay, hold on a second. Let me repeat this calculation. 5 plus 4.23 multiplied by square root of 3 divided by 2. Yeah, this is 8.66. I'm sorry. This number is not 5. This is 8.66. My apology. I know I did this calculation yesterday, so it was a bit different. Okay, so let me correct it here as well. So this is minus 8.66. And when we do this calculation, it is 9 divided by 2 times 8.66. So this comes out to be 0.519, so I will like 0.52 meters. Okay, so the initial distance was 2.25 meter, and this distance, it is 0.51 meter. Okay, so the total distance now I can calculate by adding these two distances. So 2.25 plus 0.52, 2.25, yeah, this comes out to be 2.77 meter. Okay, so I hope you understand all the logic here behind this, that what we are doing. Okay, this is the most important thing. Okay, so let's move on to question number 6. Okay, we are given that a particle is moving in a straight line and its distance from a fixed point as a function of time is given by this expression, and this expression is valid for first 3 seconds. So find the maximum velocity. Okay, remember the maximum velocity we can find by differentiating this velocity expression and putting it equal to 0. So I will differentiate this expression, and that is going to be 3 by 2t plus 1, and its power is 3 by 2 minus 1 is going to be 1 by 2 into derivative of 2t is 2 minus the derivative of this is 4t. Okay, so we need to put the derivative equal to 0. Okay, this 2 cancels with 2. I can write it as 3 times 2t plus 1 and power half and equals 4t, right? If I square on both sides, it will become 9 into 2t plus 1 equal to 16t squared. So if I open this, it is 16t squared, and 18t become negative over there, minus 18t, and 9 also become negative 9 equal to 0. Okay, so let me make sure that I'm doing it correctly. Yes. Okay, so let's solve this quadratic equation to find the value of t. So this t is going to be minus b plus minus under the root b squared. So 18 squared minus 4 into a into c is minus and 7 plus and 9 here. And divided by 2a, so 2 times 16. And when I simplified this whole thing, I got two answers, 1.5 and minus 0.375. So of course, I'm interested in the interval 0 to 3, so I will not consider this one. Okay, so the speed is maximum at time 1.5 second. Okay, speed could be maximum or it could be minimum here, right? We know that. So how can we know that it is maximum here? There are several ways. If I try to calculate, okay, we have the interval 0 to 3, right? 0 to 3. So at 1.5, the speed is extreme. So it is either maximum or minimum. So if the speed at 0 and 3 is higher than 1.5, then of course this is the minimum. And if these speeds are low, then this is the maximum. Okay, so let's calculate the speed at 0. Let me calculate the speed at time. So when time is 0, how much is the speed? You see, time is 0, so 1 power anything is 1. Okay, 1. And then this is 0, so this is going to be 1 only. When the time is 1.5, okay, 1.5 times 2 is 3, 3 plus 1 is 4, 4 square root is 2, 2 to the power 3 is 8. So it is going to be 8 minus 1.5 square. We do it. Okay, so this is 8 minus 2 times 1.5 square. So this comes out to be 3.5. So 3.5. And when time is 3 seconds, let's calculate this quickly as well. So this is 7 power 1.5 and minus 2 times 3 square is 9. So the speed is 0.52. So you can see that at 1.5 the speed is maximum. It's not the minimum. Okay. So our answer is that time is equal to 0, sorry, is 1.5 second. This is my answer for this part. Okay, and then find the maximum velocity of P in the interval. Okay, sorry. So yeah, okay, so yeah. So at this time, this velocity is maximum and that velocity is 3.5. Okay, so this is our part A. Now in part B, we are told find the distance of P from A at the instant when the it has a maximum velocity. So that means we need to find the distance from between time 0 to 1.5. Okay, in this time, how much the distance it has traveled. So how will we do that? You know that the distance can be found by integrating the velocity, okay, from this time to this time. Okay, see, in our case, this distance is going to be, now velocity is, uh, we know it is 2t plus 1 power 3 by 2 minus 2t square. So this whole thing into dt, and we've integrated from 0 to 1.5 because we have to find the speed. This is ever in this in this range. Okay, so this is, let me integrate it in this way, 2t plus 1 power 3 by 2 dt 0 to 1.5 and minus 2 t square dt 0 to 1.5. Okay, here, if I put 2 here and 1 by 2 here, no problem. Okay, so 1 by 2 and the higher functions power n is complete derivative. So power plus 1, so this is 2t plus 1 power 3 by 2 plus 1 is 5 by 2 and divided by the same 5 by 2. 5 by 2 is basically 2.5. And it has a limit from 0 to 1.5. Now minus 2 t squares integral is t cube by 3. Am I right? Again 0 to 1.5. Okay. So this 2 times 2.5 is 5, 1 over 5. Okay. When I put upper limit, 1.5 times 2 is 3. 3 plus 1 is 4. 4 square root is 2 and 2 to the power 5 is 32. I hope I'm clear. And then I put the 0, t for 0, it is 1. Minus 2 by 3 when I put upper limit 1.5 power 3, so 1.5 raised to the power 3 is going to be 3.375, and when I put 0, just 0. Okay, so this all comes out to be 31 by 5 minus 2 times 3.375 over 3. So I did this calculation, it is 3.95 and it's meters. Okay, I hope this is all clear. No confusion should be there. Okay. Okay, now let's move on to the last question of this exam. Question number 7. Okay, this is also a very interesting problem that we have an inclined surface. Okay, and there was an object, its weight is 3 kilogram, and it was moving up with a speed of 8 meter per second. Okay, and we just pushed it and left it. Okay, so when we left it at that instant, its speed was 8 meter per second. Now the thing is, it will keep going up, and of course it will stop at some point, right? And then it will slide back again. So when it reaches here, what would be its speed again? Okay, this is what we have to find out. You see, if this surface was absolutely frictionless, there was no loss of energy in against the friction, then whatever was its potential in kinetic energy here, it will convert into potential energy, and that potential energy will convert back to the kinetic energy, and it will have the same speed with that's 8 meter per second when it comes down. But now due to the friction, it will have its speed is going to be less. And whatever the new speed is, that we need to find out. Okay. Okay, so at this point, what was its kinetic energy? It was half mv square, so half, and m is 3 kilogram, and v is 8 square. Okay, this was its energy. Okay, this energy is okay. So let me calculate this thing. This is kinetic energy, and it is going to be 8 square. I calculated it somewhere here. Yeah, 8 square and 3 by 2. This is 96 joules. Okay, this is its kinetic energy over here. Okay, now what's the frictional force? What's force of friction? Remember, it is the coefficient of friction into the normal force. Coefficient of friction is given as this one. So this is under root 3 over 12. And this normal force is, you remember, it is mg cos theta. Okay. Do we know the angle? Yeah, angle is given as 30 degree. Okay. So m is how much? 3 kilogram, and g is 10. So this is 30. And cos of theta is under root 3 over 2. Okay. Uh, so this all is simplified into 3 into 30 over 2 into 12. So it is going to be 3.75 Newton. Okay, so the frictional force is this much. Okay. So when it reached at the top, when its speed becomes 0, okay, so when its speed is 0, it has traveled some distance. Okay, we do not know how much is distance. Let's assume that it traveled the distance of s meters, right? Okay, now how much is the vertical distance it has achieved, the vertical height? Okay, because the potential energy, it is equal to mgh. Okay, so in this particular case, m is 3 kilogram, g is 10, and h is basically this s into sine of 30 degree. Okay, so I do not know how much is the s, but whatever is the s sine 30 is the potential energy. So that is going to be 30 and half and s. So this is 15s. Okay, 15s joule is the potential energy over here. Okay, now you can see that the kinetic energy over here, it is equal to potential energy plus the work done against friction. Work done against friction. Okay, so kinetic energy was 96. This is equal to potential energy is 15s and work done is 3.75 into s, right? Because this is the force of friction and if the distance is s, then the work done against the friction force is going to be 3.75 s. Okay, I hope this is all clear. So from here, I will try to find out the value of s. So s is going to be 96 divided by 15 plus 3.75. And it comes out to be 5.12 meters. Okay, so this is the distance it is traveled before coming to rest. Okay, now uh, at this point, when it has a maximum height, what is its potential energy? Sorry, potential energy. As we said, it is going to be 15s. So now we know the s. I can calculate the value of this potential energy. 15 times 5.12. So this comes out to be okay, 15 times 5.12. So this is 76.8. Okay, you see, in the beginning, it has a potential energy of, sorry, kinetic energy of 96 joule. Okay, but the minute it reached the maximum height, it has only 76.8, much less than 96. Rest is wasted in the friction. Okay, now it will come down, it will slide down. Okay, and whatever its potential energy over here, it will convert into kinetic energy and the friction energy work done against the friction. Okay, so this potential energy, which is 76.8, it is equal to uh, kinetic energy when it reached down, which is half mv square plus work done against friction. We know the frictional force is 3.75 into the distance it has traveled. Remember, this is the frictional force. Okay. So, and of course, this S, we know, I don't need to write the value. Okay. So this distance is 5.12. Okay. Now, in this equation, there's only one unknown V. Of course, M is 3 kilogram. So I can substitute 3 for this. And I can solve this equation to find the value of V. You can see that V square 3 by 2 is equal to 76.8 minus 3.75 into 5.12. So 7 minus 3.75 times 5.12. So this comes out to be 57.6 and V would be equal to 2 by 3 into 57.6. Okay, times 2 divided by 3. And when we take its square root, it comes out to be 6.2 almost. 6.2, yes. 6.2 meter per second. Okay, so this was the solution for our seventh problem. I hope you understand the whole logic. Okay, this is important that you need to learn the whole logic. What are we applying over here? Okay, I hope you understand everything. If you ever have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.